Hi class, welcome back. And today we're going to talk about section 8.2, combinations. So we are still talking about the counting rules, right? So we talk about the counting rules. Basically, we are counting how many possible situations because we talk about the probability. Sometimes the events and the sample space is too big and we cannot write out every element. So that's why we're going to use the counting rule. And we have two kinds. We call this a permutation and we have a combination. We talked about the permutation last time. So the permutations, the key part is what? Permutation is what? Order what matters, right? That means which one you take out first or which one you take out the second, it make a difference. So if you want to take 3 people out of the 8 people, then the first one you take out, say, be the president. Second one be a vice president, then the third one be a secretary. So the order does matter. Or the combinations here is we said order is not matter. So it doesn't matter who is take out first, who is take out later. So for example, if out of the 8 people, I want to pick out the 3 people to be the committee, and I don't care, so all these 3, they just serve as committee members. So who got who is taking out the first, who is taking out the second, who is taking out the third, does not matter, right? So this is what we call this the combination. Okay, so the combinations here, the notations here, the combination we use, we said is CNR. That means the out of the N, that means how many times out of the N elements, right? Then taking out, we're taking the R at a time. So every time we take out the R elements, then we want to figure out how many different ways. And then the combination, remember, the order does not matter here, right? So the way we define as the CNR, or, in the TI calculator, the way they do is they write like this way. So this is the TI-84 calculator. Okay, so the CNR, the ways here, this is the formula, is n factorial, and then you will have r factorial, then you will have n minus r factorial, okay? And so this is the CNR, so that is the combinations. Okay, so let's do, so I'm going to show you one, we're going to do manually, and then we're going to use TI calculator, we'll see, we'll get the same numbers here, right? So if I want to take a CA3, right? So if I want to take a CA3, so this is my N, this is my R. So what I will have is n factorials, right? N factorial is a factorial. Then I have r factorial is 3 factorial, n minus r, right? So it's a minus 3, so it's 5 factorial. So you can just, use your calculator, put the factorial in, or you can say this is 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8, right? And then the 3 factorial is 1 times 2 times 3. Then the 5 factorial is 1 times 2 times 3 times 4 times 5, right? So you can list all, and then you can say, okay, let's see here. This is 1, 2, 3, 4, 5. I can cancel this is 1, 2, 3, 4, 5. Then 2 and 3 is 6. I can cancel with 6 here. So what is my final answer? My final answer is 7 times 8, 56. Okay, and now let me show you how to use the TI calculator to input here. I'm going to switch the screen sharing and to the TI calculators here. Okay, so here's the TI calculators, right? So we are doing 8 take 3s here, right? Okay, so let me clear this out. Okay, 8 takes 3. So first things you put an 8. Okay, then you go math here, right? Then you go to PRB, right? So you go to PRB. Did you see NCR here? Yeah, so that is N, that's a combination of N take R. So you put an enter, then you take a 3, then you put an enter again. Did you see here the 56? That's exactly the same like we got, by doing the hand calculations, right? Okay, so remember, right? So, the use your calculator is a lot easier. So I'm going to switch back to the whiteboard again. Okay. Okay, so now we're going to do some more examples so you will be good at it, right? Okay, so let's take a look at examples here. Another examples here. Okay, so a manager. Okay, so this problem see here is a manager. And must select 4 employees for promotion. For promotions. And then now I have 12 employees. They are eligible. So how many different ways? So we can use C what? 12, and I'm taking 4. So that means, it doesn't matter, both all these 4 people going to get, the same promotion. So who is getting taken out first, who is getting taken out second, does not matter. See here. So now let's take a look. Let's try to use the TI-84 calculator one more time. So I'm going to stop sharing. I'm going to go to the TI calculator one more time. Okay, so we'll do again. So this is how many? 12, right? Then I go to the math. Then I go to the PRB, then go to NCR. So 12, I'm choosing 4 people. So what is the number? 495, right? So that's what we got is a 495 here. So this is a 495. So you can try to, practice your calculator. Okay, so now if I change this way is a little bit different, okay? So if I say in how many different ways, okay, can this 4 employee, be chosen to be placed in 4 different jobs? Okay, so now the order does matter right now because the first one they choose, the first employee chosen will be placed in the first job. Then the second one will be placed on the second job. And then those jobs, they are different. So who got chosen first, who got chosen later it doesn't make the differences because they will be going to the different job. So this is the one, what? This is what we call it here. This is older what? This is older matter. So which one I choose first, which one I choose second, it doesn't matter. So what I need to do here, so instead of the C, I'm doing what? P's, right? So it's a permutation, it's 12 and the 4. Then I don't know, you guys still remember how to use the TI-84 for the permutation. So it's the same things. So let's take a look. Let me switch it back to the TI-84 again. Okay, so now this is the same thing. You say 12, then you do a math, then you do a PRB. Now you do NPR, right? Then you have a 4. So you have a 11880. Okay, so you have that many different, the different way to put the people in the 4 different jobs. So this is 11880. So you use the permutations, all right? Do you get it? Okay. Okay, so now let's take a look at the next examples here. So the next examples, okay, so I'm choosing the marbles are being chosen without a replacement. From a bag. With 16 marbles. With 16 marbles. Okay, so in here, we assume all the 16 marbles, they are different. So first one here is how many samples I can have. Of 2 marbles can be chosen. So that means if I choose the 2 marbles every time, right? But you know that I just want a sample. It doesn't matter which one is first, which one is the second, right? So order does not matter. So this is a 16. I take a 2. So I calculate here is 120. You can try to, practice your calculator to see, that you will get the same ones or not, okay? So now the part B is here. So we said how many samples? How many samples of 4 marbles can be chosen? That means if I chosen 4 marbles, still I don't care, I just grab 4, right? So here will be C the 16 to the 4. Then you put it into the TI calculator to verify to see you can get a 1820 or not. Okay, that would be a good way to. Okay, so continue with the same things here. So now, so in here, if we say if the bag, okay, contains 3 yellow, okay, 4 white, and 9 blue marbles. Now I want to find how many samples of 2 marbles can be drawn. Which both marbles are blue. Okay, so in here, so we said, for these ones here, we have 3 yellow, 4 white, and 9 blue. And now I'm going to take 2 marbles out, but I only care to see how many samples I can get 2 blue marbles. So out of the 9 marbles, I choose 2, right? So I only pick from the blue marble. So it's 9, take 2. So you put it into a calculator, it will give you 36. Okay, so now let's take a look at the next examples here. I think after this, you should be pretty good at this, right? So we say in this club with 9 male and 11 female members. So this club, we have 11 members. How many? So I'm going to choose a committee. So how many 5 members committee? Okay, can be chosen. If, okay, so let's take a look, right? So for this ones here, remember we have 9 male and 11 female, okay? So the question is say, how about this committee is all men? That means that when you pick, how many males we have? 9, right? So if all men, that means you only pick out from the 9, you choose 5 people. Okay, so this one will give you 126. How about in here? They say, how about if I have all women? Right, so the women has 11. So that means I need to take the 5 members from the 11. So it's C11, 5. So this is a 462 here. Okay, so the part C is here. They say, what happened to this committee? I'm going to have 3 men and 2 women. Okay, so here, okay, so we already know for the 3 men, I can do, I have 9 men, right? So 9, I take it to 3. Then for the women's here, I have 11, then I take 2. Now, remember we talked about in the previous chapter, the key word, right? So this is the end. So what is the end mean? End is multiplications, right? So we are times it. Okay, so be very careful, right? So that's why we said over is addition and is multiplications here. So in here, it turns out this will be equal to 9 take 3, you have 84 times 55. So you will have 4620 here. Okay, so it's very important. So here they want to show you is the end. So when you do end, then you will need to do the multiplications here. Okay. Okay, so let's take a look in other examples here. Okay, so the other examples here. Okay, so here. Okay, so these examples here. This is the where we combined with our like a probability rule last from the last chapter. Okay, so this is if a baseball coach. So this baseball coach has 5 good hitters and 4 poor hitters. Okay, so on the bench. And the chosen, so choose. So this coach want to choose 3 players at random. at random, right? Okay, so now we want to see in how many ways, okay, so the coach can choose at least 2 good hitters, right? 2 good hitters. Okay, so now in here, so we said I need to choose 3, right? So I have 5 very good hitters, and I have 4 poor hitters, right? I'm going to choose 3 players. So when I choose 3, I said I want to have at least 2 good hitters. So what is at least mean? So when we talk about at least, right? At least 2 good hitters. That means that I'm going to have 2 good hitters, at least, right? 2 good hitters, or 3 good hitters. Correct? Okay, so now for the 2 good hitters, I know how to do that. So that means, okay, so let's break it down one more steps here. 2 good hitters, so that means 2 are good, and 1 is poor, right? So 3 are good, that means 3 are good, and I choose 0 is poor. Okay, so that means and 0 is poor. Okay, so the first is here, you see, we have a few keyword here, right? So this is and. Okay, so now I know how to choose the good one. So that means the C, right? I have a 5, I take a 2. Then choose a poor one. I have a 4, I take 1s, right? And also we talk about, because we said this is and, so we do the multiplications. So the same way is here, so 3 good ones, so that means C the 5, 3, right? And 0 poor ones, so the 4, I'm choosing 0. And because this is and again, so we know and in the probability, so it's times, correct? Okay, so this one is times. So now we need to combine this statement here. So we say I have 2 good hitters and 3 good hitters, or 3 good hitters. So if you see or, remember what is the things we do here? We use, so or is the addition and is multiplications, correct? Okay, so now you put it into the calculator, and so this will be, so this is 40, and so if you do this one, this is 40, and this is 10. So you add them together. So what is the answer? So total you will have 50 different ways, right, to choose it. So need to be very careful. That's what we call about the combinations, right? So the combination, so remember, the order does not matter. I don't care who is pick up the first one, who is pick up the second one. And then sometimes the problems here are going to combine with the probability rules like and, or, those things. So remember, right? So or, right? So the keyword or is what? So the or, that means you use the additions, right? And the keyword when we talk about and, that is the multiplication. Okay, that's how do we do that. And so I'm going to stop the video here, and so review it, and then when you finish review it, and go ahead to try to do some of the classwork to see you be able to do that or not. Okay, okay, so I was so here Okay, so I guess I will uh,